Welcome back to our lesson. Previously, we examined prime factors, HCF and LCM. We explained why these are very important concepts that we need to know and how they can help us to do many useful things in mathematics. Now we want to look at fractions, decimals, and percentages, okay? And it's all about competency in manipulating numbers. As you will see further into our lessons, if we are able to easily convert fractions, decimals, and percentages, or even handle them easily, then we will be very effective in solving more challenging mathematical problems. So the topic here is fractions, decimals, and percentages. Okay, so this will be a slightly long video because each of them is a very big thing in maths. Okay, when I start looking at fractions, we will start looking at the terminologies around fractions. Then we will start looking at many things under fractions. So first of all, let me give an overview to what we will be doing in this slightly bigger topic. Fractions, we will be looking at the terminologies. Okay, as I said, in maths, if you know the right name for the right concept, or you are able to explain what a term is, it's useful for you because some of the questions only present technical terms, and it is up to the student to understand what the question means by the technical term and then solve the problem accordingly. So if a math problem has a technical term, let's say find the denominator of something, and you don't understand denominator, straight away you are stuck. It's very difficult for you to move on. So we'll be looking at some terminology in fractions. Then we'll be looking at types of fractions, types of fractions, and then operations. Operations. Okay, so that will be for fractions. Then we will come to decimals and then we will come to percentages. But I don't want to overwhelm you, so let's stick with fractions for now. So in this session of this video, we want to look at fractions. Fractions is a very important topic in maths, and if you have been following our lessons, you see that one of the earlier lessons, we were looking at types of numbers, and we were able to define numbers based on whether they are able to be written as a fraction or not. For those of you who remember, we talk about real numbers, and then we broke them down into two brothers: rational numbers and irrational numbers. And we said that the rational numbers are numbers that can be expressed as fractions. Okay. At that point, well, you may or may not know exactly what fraction is, but that is the purpose of this channel. We are now coming to explain exactly what fractions are. Then we said that for the irrational numbers, they simply cannot be written as fractions. Okay. So fractions is a very important concept in mathematics. And today we are looking at fraction thoroughly. We will not leave any stone unturned. We are looking at fractions thoroughly in this lesson. Now, what are fractions? Fractions are also the same as we use in everyday language. Fraction is a portion of a whole. Fraction is a portion of a whole. Okay, so you have a whole pizza. Okay, you have a whole pizza. So here you can drop your comment on your favorite kind of pizza, whether you like meat feast or uh, cheese and tomato or whatever. But you have a whole pizza and then it's divided into bits. A portion of the pizza will make a fraction. So let's say this portion will be 1 out of 1, 2, 3, 4, 5, 6, 7. So that portion of the pizza will be 1 over 7. The 1 over 7 is the fraction that defines the portion of that pizza. Okay, part of a whole, but you can take that out. Maybe you have 7 people each wanting a piece of the pizza. Then we say, hang on, we have to be fair. If we have to be fair, then everyone gets 1/7. So we are 7. We are dividing the pizza into 7 equal parts, and everyone gets 1. So the portion of the whole that each individual gets is the fraction. And fraction is very important in maths. It enables us to define parts of something. Okay. In life, you can't have it all. Sometimes you have to settle for a part of something. So you have siblings, you have a brother and a sister. There is one piece of cake. You can't have all the cake. You have to settle for a portion of the cake so that your brothers and sisters can also have their bit. So that is what fractions are for. And they are very, very important. As we go through subsequent topics, you will see that fractions can become more complicated, but so long as we are building upon the concepts precept by precept, when we come to even complex fractions, it will be easy for us to work through because we have understood the basis. And this lesson is to give you the basis. Okay, so let's look at some terminologies around fractions. So we are looking at terminologies in fractions. So one, a fraction is in the form of one number sitting on a bar above another number. So let's say A and B are the different numbers making a fraction. This A, the one sitting at the top, is the numerator. Okay, and it's very important that we understand this. The one sitting at the bottom is the denominator. Okay, and why is it useful for us to know these terminologies? Because in a certain question, they can describe a fraction in these words. The numerator of a fraction is 2. What is the possibility that this fraction is greater than 1? Then they will give possible answers. A, when the denominator is 4. B, when the denominator is 1. C, when the denominator is 3, and so on and so forth. Now, imagine coming across such a question and you don't know what a numerator stands for. You don't know what a denominator stands for. You simply cannot answer this question correctly. So terminology is very important in maths, and that's why we are taking time to go through all this. So that is the main structure of a fraction. You have a number sitting on top of another, and they are divided by a bar. And the one on top is the numerator, and the one below is the denominator. So that's the first part of terminology in a fraction. 2, we have what we call proper fraction. So I told you that in life, things are usually in opposites. So if we have proper fraction, then we definitely have improper fractions. So what are the differences? A proper fraction is simply a fraction where the numerator is smaller than the denominator. Okay? Numerator is smaller than the denominator. Okay, so you see how useful it is for us to know the parts of a fraction. So I can simply define what a proper fraction is by referring to the magnitude of the numerator and comparing it to the denominator. So it's as simple as that. A fraction where the numerator is smaller than the denominator is a proper fraction. So let's look at examples. 2/5. The numerator is 2, the denominator is 5. The numerator is smaller than the denominator. This is a proper fraction, okay? 6/15, 25/32, 19/47. All these are proper fractions. Why? Because the number sitting on top, the numerator, is smaller than the denominator. So that is what we mean by a proper fraction. And again, it's very important that we know the difference between a proper fraction and improper fraction. So logically, an improper fraction will then be a fraction where the numerator is bigger than the denominator. Okay, a fraction where the numerator is bigger than the denominator. That is an improper fraction. It's not right. Okay, now look at something. If you are going to sit on top of me, then I should be stronger than you, isn't it? Then we can maintain a balance. So, whereby you are bigger and stronger than me, trying to sit on a smaller one, that is not proper, literally. So, we know what we can tell ourselves when we are trying to distinguish between a proper fraction and an improper fraction. So, that becomes an improper fraction. That becomes an improper fraction. That becomes an improper fraction. And so on. Now, in maths, we like things to be proper. We like things to be proper. So if we encounter an improper fraction in maths, it makes us uncomfortable. Okay, maths is a beautiful subject. And we want everything to be proper. We want everything to be in order. We think that it's not fair for a big number to be sitting on top of a small number. That is going to cause a lot of distress. So because of that, we have what we call a mixed fraction. Mixed fraction. So because we like everything to be proper in maths, when we come across an improper fraction, we try and convert it to mixed fraction. We try and make it proper. Okay. But remember, one thing that is never allowed is for you to change the value of anything in maths. You can only rewrite it in another way, but the value must be maintained. So the fact that we have an improper fraction like 15/9, that makes us uncomfortable. We can't just simply flip it upside down and say, I'm changing it to make it proper, so it's 9/15. If you do that, you have changed the value. And in maths, one thing we never do is to change the value of anything. We can simply rewrite it in another way that will feel improper to us, but maintain its value. So if we have an improper fraction in the form of 15 over 9 and we are not comfortable with it, all what we can do is to make it a mixed fraction. A mixed fraction will maintain the value of 15 over 9, but we will no longer have a bigger number sitting on a small number. We will no longer have a numerator being bigger than a denominator. We will have a mixed fraction. Okay, so that is a mixed fraction. A mixed fraction simply is a combination of whole numbers, whole number, and a fraction. So it's mixed. It's not entirely a fraction because part of it is a fraction, part of it is a whole number. That is what is presented as a mixed fraction. So the next thing we want to look at is to be able to move an improper fraction to a mixed fraction and then move a mixed fraction to an improper fraction. So first, let's start with an improper fraction to a mixed fraction. And then when we finish, we will try the reverse. We will be given a mixed fraction and then we will try and move it to an improper fraction. So improper fraction, let's use our usual 15 over 9. We want to change this to a mixed fraction because we are not comfortable with the idea that a bigger number is sitting on a small number. That will cause a lot of distress. So what do we do? What is the procedure for changing an improper fraction to a mixed fraction? I always like to give procedures and steps. So let's look at the steps involved. 1. Find the biggest, find the number of times the denominator can divide into the numerator. And I'm taking time to write all these steps so that you can also make notes and then easily refer to it, because sometimes if you just watch a video and you there and then you feel like you know what to do, but subsequently in the classroom you are presented with an exercise and you realize you have forgotten the video that you watched. So if we document the steps and in your own free time you can look through, then that will be useful for you. So first of all, find the number of times the denominator can divide into the whole number. So 9, how many times can 9 divide into 15? We don't want to go beyond. Okay, so if we attempt 2, we actually need to have 18 or more, but we don't have up to 18. So it can only divide into 8 once. So let's put that one there. Okay, now 2. Determine the remainder after the denominator has, or let me make it easier, after the numerator has been divided by the denominator. So 9 goes into 15. The remainder is 6. The remainder is 6. So next, make a new fraction in the form remainder over original denominator. So the new fraction is the remainder, which is 6, over the original denominator, which is 9. Okay? And we add that to the whole number gotten from stick that by the whole number obtained from 1. Okay, the first step, we try to figure out the number of times the denominator can divide into the numerator, and we find out it is 1. So in the fourth step, we are sticking this new fraction we made by it, so it becomes 6 over 9. So 15 over 9 can be written as a mixed fraction of one whole number, 6 over 9. Okay, so let's try another example quickly, then we will move on. I have 27 over 6, and I'm meant to make a mixed fraction from this because it's an improper fraction. We have a big numerator over a small denominator. So first, I'm going to determine how many times can 6 go into 27 without going over 6, 3, 18, 6, 4, 24, 6, 5, 30. So I must stop at 4. So 4 whole number. Now 6 goes into that 24. What is the remainder? 3. So 3 over 6. 4 whole number, 3 over 6. 4 whole number, 3 over 6. Okay. As simple as that. As simple as that. Let's try another one. In fact, let me give you one to try. So we have 35 over 18. Try this one. Try this one. And then whatever you get, you can put your answer in the comment. Try this one. Change 35 over 18 to a mixed fraction. Change 35 over 18 to a mixed fraction. And you can follow the step-by-step procedure here. And you can change 35 over 18 to a mixed fraction. Now let's go on. We have been looking at improper fraction to a mixed fraction. How about when I have a mixed fraction and I'm going to change that into an improper fraction? This time I want you to change something to an improper form. Mixed fraction to improper fraction. How do we go about this? So let's say I have 6 whole number, 2 over 3, or 7 whole number, 4 over 7. I have this mixed fraction and I'm supposed to change them into improper fraction. It's very simple. We are literally reversing what we did when we were trying to move an improper fraction to a mixed fraction. We are reserving it. So for instance, where we were dividing, we are going to multiply. Where we were finding the remainder is essentially a subtraction process. We are going to add here. So here, it's very simple. Instead of the steps, I'm going to use some signs. So multiply, okay? Multiply. Whatever you get, when you multiply, you get the product. Add, and then maintain the denominator in the fraction. Maintain the denominator in the fraction. So 3 times 6, 18. 18 plus 2, 20. Maintain the denominator, original denominator. So 6 whole number 2 over 3 simply becomes 20 over 3. Improper fraction, 20 over 3. So let's try again with this one. Multiply. That gives you a product. Add. And that gives you the numerator. The new numerator. And divide by the original numerator. So 7 times 7, 49. 49 plus 4, 53. 53 becomes the new numerator, and then divide by original denominator, which is 7. Okay, so that is how we make a mixed fraction into an improper fraction. This is very simple. Give yourself some random mixed fractions and change them to improper fraction. And then give yourself some improper fractions and change them to mixed fraction. Now, you may not necessarily get a question about this, although you could. Okay, so for instance, in England, the GCSE exam, it starts with fundamental knowledge. In the first 5 questions or so, you could get something like this: change 6 whole number 2 over 3 to an improper fraction, or change 7 over 3 to a mixed fraction. You could get. Other exam boards around the world could also try and test the fundamental knowledge of students on certain basic things like this. So you could get. But the most important reason why I'm taking time to go through this is that when you are solving more complex problems, as you go through the steps, sometimes it's easier for you to progress by changing an improper fraction to a mixed fraction. Or sometimes the reverse is true. You have a mixed fraction and it's creating a lot of problems. You have a mixed fraction trying to add up to a proper fraction to multiply something else, and you don't know what to do with the whole number attached to the fraction and so on. In that case, you are free to change a mixed fraction to an improper fraction so that they can align. So you have a single fraction adding or multiplying or subtracting another single fraction. Then you can go on subsequently to find the final solution to your problem. So these are some of the reasons why we really need to be competent in manipulating these forms of fractions. So now let's go back to the original plan. So we have been looking at mixed fractions, improper fractions, and we are converting them. The next thing that we want to look is equivalent fractions. Equivalent fractions is very important. Equivalent fractions are very important. they can easily help us to add or subtract fractions. Okay, I know in the previous lesson we said that one of the purpose of finding LCM is for us to be able to add or subtract fractions. Okay, so that is one method of adding and subtracting fractions when we use the LCM to go through some procedure. But sometimes if you can't be bothered going to look for LCM and all those things, you can use what we call equivalent fractions to easily add or subtract fractions. So let's quickly go through equivalent fractions. Equivalent fractions. So what are equivalent fractions? Equivalent fractions have the same magnitude. They have the same value. They look different, but when you drill down, they represent the same quantity. Okay. Equivalent fractions look different because obviously they are made of different numbers, but they have the same value. Okay, equivalent fractions, they look different, but they have the same value. So, what are examples of equivalent fraction? 2 over 3, 14 over 21. These are equivalent fractions. They look different. 2 over 3 is different from 14 over 21. They are not even made of the same numbers. But what is the value? 2 over 3 and, oh no, hang on. Yeah, we are right. 2 over 3 and 14 over 21, they have the same value. How? If I am to divide this by 7, it will give me 2. This by 7 will give me 3, and I have the 2 over 3. So 2 over 3 and 14 over 21 are equivalent fractions. They are equivalent fractions. Let's look at another example. 5 over 6 and 25 over 30. They are equivalent fraction. If you get a calculator and punch these two different fractions, they'll show you the same decimal. So, for instance, let me get my calculator. 5 over 6. 5 over 6 is 0.8333. 0.83 recurring. How about 25 over 30? 0.83 recurring. So you see, equivalent fractions, they look different, but they have the same value. 5 over 6 appear to have nothing in common with 25 over 30, except their values. They are both 0.83 recurring. 0.83 recurring. So these are equivalent fractions. Now, what is the purpose of equivalent fraction? Equivalent fractions will make us work out addition and subtraction of fractions very quickly. Addition and subtraction of fractions very quickly. So, what do I mean by that? Let's look at something. If I give you 2 over 3 plus 7 over 9 to add, okay, I give you 2 over 3 plus 7 over 9. Now, when we were in primary school, we used to add some very simple fractions. So let's quickly roll back a bit to year 2 or year 1 or year 3, wherever, depending on the country you are based. And let's look at what we were taught in primary school about adding fractions. So we were told that if you have two fractions, 2 over 5 plus 3 over 5, So long as the denominators were the same, so here the denominator is 5 and here the denominator is 5. So long as they are the same, you can just carry one of the denominators and then the top ones you add. Okay, so this becomes 2 plus 3, 5 over that, and you have 5 over 5. Coincidentally, this gives us 1. I didn't even think about it when I was giving the example, just a random fraction. But that is it. But what if the denominators are not the same? Then you can use this trick. So you have two options. You either have to find equivalent fraction of one of them and bring the denominators to be the same before you carry on using the trick that we were taught in primary school. Or you go for what we call LCM. Okay, so this brings us to addition and subtraction of fractions. Addition and subtraction of fractions. So here, I can either find an equivalent of fraction and change this to have the same denominator as that, okay, and then use it. Now, not every fraction can be solved by using equivalent fraction, because if the denominators are not common multiples, it will be almost impossible for you to solve addition or subtraction of fractions by using equivalent fractions. Then you have to go to the other method, which is using the LCM. Okay, so here, luckily for us, 3 and 9 are multiples, so we can find equivalent of that. We can multiply with a number, both the numerator and the denominator, so that the denominator becomes the same as that one. And the number I can think of is 3. So I'll multiply this by 3 and multiply this by 3. In maths, when you multiply a numerator and a denominator by the same number, you have not changed its value. Its value is preserved. You have only changed it to an equivalent fraction. So here, I'm going to get 6 over 9. Okay. Now, if I bring this 7 over 9, then now you can see, as we were taught in primary school, 9 and 9 are here. So I'll simply carry the 9 over and then I'll add the two numbers on top, which will make 13. So this becomes 13 over 9. So that is how you can use equivalent fractions to solve a problem. The same goes for the subtraction. All what you do is to respect the operation. Okay. So for instance, let's use equivalent fraction to solve another one. So I have 5 over 8 minus, I have 5 over 8 minus 1 over 16. Okay. So this is a very simple example. 8 and 16 are multiples, so I can easily find an equivalent fraction of that one such that its denominator is now similar to the other one. So if I multiply both parts of the fraction by 2, I'm going to get 10 over 16. 10 over 16 minus 1 over 16. Now that we have a common denominator for both fractions, I can carry the 16 over and I can just do a simple arithmetic of 10 minus 1, which is 9. So I get my 9 over 16. I get my 9 over 16. So that is how you can use equivalent fractions to solve fractions. How about when I'm given a fraction like this? Now, 4 is not a factor of 7, or 7 is not a multiple of 4. So we can't straight away did what we did before. What we can then do in such a circumstance is to change both. to an equivalent fraction where they both have the denominators of this and that. Okay, so I'm still determined to use equivalent fraction to solve this. I don't want to use the LCM approach yet. What then can I do? I can multiply this fraction. I can multiply this fraction by this number. Then I will multiply this fraction by this number. And that will give me equivalent fractions that I can use to continue solving my problem. So still using the concept of equivalent fraction, we don't want to go the LCM route yet. We want to use equivalent fraction, but we were not lucky. We didn't get denominators that were easy multiples of each other, but we are still determined to use equivalent fraction. So we cross multiply essentially. So I'm taking 2/7. No, let's keep the colors consistent. I'm taking 2/7 in the green box. And I'm now multiplying both parts of this fraction by 4. So multiply here by 4, multiply here by 4. That gives me 8/28. So 8/28 is the same value as 2/7. So technically, I've not done anything to it. I've not reduced the value or increased the value or anything. It's just, I've just found an equivalent fraction for that. And then the usual minus comes. And then now I'm going to multiply this 3/4, both parts by 7. And that gives me 21/28. So 21/28. So what I have done, I've used the concept of equivalent fractions to make both fractions have the same denominator. Then I can simply go ahead and do what I was taught in primary school. Carry the denominator over and then perform the operation at the top. So 8 minus 21, 8 minus 21 becomes minus 13. Minus 13. So my fraction, my answer then becomes negative 13/28. Okay, if I attempt to do this operation. So that is how you can use equivalent fraction, even if the denominators are not in multiples. Okay, now whilst we are at the performing operations on fractions, let's look at the other method. Let's look at the other method. 2/7 plus 3/5. Okay, we can either use equivalent fractions to do this, or what we need to bear in mind is that the denominators are not simple factors or multiples of each other. So we will essentially create an equivalent fraction by using this denominator to multiply that bit, and then using this denominator to multiply that bit. Okay, you can play back the video and make notes from what I said. Once you do that, you are going to end up getting what we call equivalent fraction. Then it's easy for you to carry on solving it easily. Okay, so first, let me make the green team 10/35 plus. Now let me make the red team 21/35. So now we have 35 equivalent fractions of each of them, carry the 35 over, and then do the operations at the top. So 31. So we have 31 over 35. Okay. And that is it. That is how we use equivalent fractions to solve problems like this. And you can apply this to everything. Now, let's look at the final thing about addition and subtraction of fractions. What if I'm giving mixed fraction and an improper fraction? Okay, something a bit weird, but something that I must solve. So I give you 7 whole number 2 over 3 plus 19 over 4. Okay, that is an improper fraction. That is a mixed fraction, and I've been given to add. There are so many ways you can do it. Some people always like to complicate problems. That is their nature. But in maths, you can start and complicate the problem and then go through a long method of solving it. Okay, I don't like that. I won't give myself additional work. The work that has been given to me in an exam is enough. So I'll rather use the approach that simplify it. Okay. Whatever it is, some people like to complicate stuff and they find it exciting to complicate things and then solve it. If that is you, it's fine. You can complicate it. But I like to simplify things and then keep it simple. So I will first of all use the method that I was taught to change this mixed fraction to an improper fraction so that I just have a single fraction adding another single fraction and I keep it simple. So quickly, 3 7 21 plus 2 23 over 3 plus 19 over 4. So I've just basically done that away. Some people can also go the other way. They'll change this to a mixed fraction, and that will be 4 whole number 5 over 4. No, let's look at it again. 4 whole number 3 over 4. So some people will change that to 4 whole number 3 over 4. Then they will go and add this and that to be 11. Then they will solve these fractions and then come and add it to it. That is also another way of doing it, but I find that to be a bit long and confusing. So I will simply change all my mixed fractions to improper fractions. It doesn't matter if it's improper fraction, so long as I'm adding them. And then when I finish and I get a final answer as improper fraction, and I'm uncomfortable with that, I can change it back to a mixed fraction. That approach becomes a little bit easy, less cluttered, and then I'm likely to get it accurate because I'm not confused with a whole mix of whole numbers, adding whole numbers and fractions, adding fractions and going to add them onto the whole number. So I can keep it clinical and simple. So here I have mine 23 over 3 and then 19 over 4. Not, I can use the equivalent fractions by making both of them have a denominator of 12. So first 4 goes to multiply this bit. So 23 times 4 92 over 12 plus 19 times 3 57 over 12. So now that I have this, I will carry my 12 over, and then I will have my 9 and 1 4. So 149 over 12. 149 over 12. And if I like, I will now change this to a mixed fraction. Okay. And using the same method that we have discussed earlier on. Okay. So this is basically how we handle fractions, multiplying them, adding them, dividing them, using equivalent fractions. And then we have also looked at all the terminologies of fraction. Now, the last thing we want to look with fractions is multiplying and dividing fractions. I told you this will be a slightly longer video because I'm leaving no stone unturned. We are looking at everything to cover all the bases. Then once we have the bases covered, we can build upon it and look at more complex math topics. Multiplying or dividing fractions is actually very easier. In my opinion, they are easier than adding or subtracting fractions. So let's quickly look at them. 2 over 5 times 4 over 8. For multiplication of fractions, unlike addition of fractions where we were hoping to get a same denominator, for multiplication of fractions, it really doesn't matter because what actually happens is that the multiplication happens for both the numerators and for the denominators. So you multiply the numerators to get your 8, and then you multiply the denominators to get your 40. And it goes. That's one difference between multiplying fractions and adding fractions. When we were adding fractions, the operation only occurred among the numerators so long as the denominators were the same. So we were forced to go and make the denominators the same. Then we carry out the operation for the numerators. For multiplication, it doesn't really matter. The numerator multiplies the other numerator of the fraction, and the denominator multiplies the other denominator of the fraction, and you get your answer. As simple as that. As simple as that. But normally, multiplying fractions will leave you with a fraction that can be simplified further. Okay, so how do you ensure that you simplify everything within the operation before you get your final answer? So the same 2 over 5 times 4 over 8, I can try and simplify them before I go across to multiply. So how do I simplify? We use the, remember HCF, we said one of the main functions of HCF is to simplify fractions. So I can simplify this fraction by using the HCF. The HCF for 4 and 8 is 4. So 4 goes into this 1, 4 goes into this 2. Okay, now we can also simplify diagonally. In fractions, we can simplify diagonally. So 2 and 2 are here. The HCF of 2 and 2 is 2. HCF of any same number is that same number. So 2 goes here 1, 2 goes here 1. So now I have 1 and 1 multiplying across, which is 1, and I have 5 and 1 multiplying across, which is 5. So my answer is 1 over 5. And this is a more correct answer because, as I told you earlier on, in maths, we expect that students will keep their final answers to the most simplified form, especially when they are fractions. So if you left your answer as 8 over 40, you are correct. But a student who leaves his or her answer 1 over 5 is more correct because their final answer reflects a more matured student. So here we can also simplify, again, using the HCF. HCF between 8 and 40 is 8. So 8 goes here 1, 8 goes here 5, and we have 1 over 5. So there you have it. You can either multiply them straight away and come and simplify your answer, or you can start simplifying the fractions within before you perform the multiplication. Either way, you will get it right. The final thing we want to look at fractions is dividing fraction. Dividing fractions is very interesting because we introduce another concept. If I have 4 over 8 divided by 2 over 3, if I have this, I'm going to do something. Just a minute ago, I've talked to you about how multiplying fractions can be so easy. Dividing fractions are not easy. They are not easy. You can try and do it manually and it can be very difficult. So what then can we do? We can do something that will change the division of fractions to multiplication of fractions. And the thing that we do is simple. The thing that we do is simple. We identify the fractions and know something about them. In order that they appear, we write from left to right. So this is the first. This is the second. Okay. In order that they appear, we will keep the first one as it is and then find what we call the reciprocal of the second part. Okay. Now, in maths, reciprocal simply is flipping something upside down. We will come to that in detail in subsequent topics, but for the purpose of doing this, 2 over 3, the reciprocal becomes 3 over 2. Just flipping it upside down in your mind, okay? So once you find the reciprocal of the second part of the problem, the fraction that comes second, now the symbol will change to multiplication. So you apply the reciprocal to this and the division becomes multiplication. So here you have 4 over 8 times 3 over 2. And you can go ahead and solve this. I like to simplify before I multiply. So 1, 2, and I have 3 over 4. Okay, so that is what we are talking about when we are dividing fractions. Again, give yourself some examples and learn how the reciprocal of the second fraction becomes change the whole thing to multiplication, then simply solve it as we did for the multiplication of fractions. So this brings us to the end of fractions.